Okay, today's lesson is on sequences in series and on general sequences. So this is start of the A-level chapter 4 for year 13 work, but we often teach this at the end of year 12. Okay, so this chapter is all about sequences, and there are lots of different types of sequences. For example, geometric, arithmetic, Fibonacci, increasing, decreasing, periodic, and these are all things you would have learned at GCSE. The first part of this chapter is just getting you used to a bit of sequence notation and a few general sequences which have different types. So first of all, we're going to kind of go straight into a couple of examples which will show you a few different types of sequences, okay? So you might want to write this down with me. Okay, so we're going to do about 4 examples. So for the first one, I've got a sequence and it is given by this formula. So x of n plus 1 equals 5x to the n take away 1, and it tells us that the first term, x1, equals 2. Now hopefully you remember this way of writing sequences from GCSE. What this is telling you, the x of n plus 1, is this is kind of telling you to get the next term, you always times 5 by the previous term and then take away 1. So when n is 1, x to the 1 would equal 2, so that's the first term of the sequence. So to get the next term of the sequence, x2, that would be when n is 2. So I'd have to do when n is 1, because I want this to be x2. So to get my second sequence, that would be like doing 1 add 1, so it would be 5 times x to the 1 take away 1, which is 5 times 2 take away 1, which gives us 9. So my sequence is going 2, then 9. And then to get the next sequence, number in the sequence, the x3, because if it's x3, that means n would be 2, 2 add 1 is 3, I'd have to do 5 times x2, take away 1. So basically you're always timesing 5 by the previous term, take away 1. So this would be 5 times 9, take away 1, which is 44. So then for the fourth term, we would do 5 times 44, take away 1, which would be 219. And then we'll just do one more. For each of these, we'll do the first 5 terms. 5 times 219, take away 1. Just use the calculator for that one. So 1094. Okay, so you could be asked about the general behaviour of this sequence, and you can see that this one is an increasing sequence. The numbers are going to keep getting bigger because each time, if you remember the rule, you're going to times your previous answer by 5 and take away 1. So for the behaviour, I could say it's an increasing sequence. And we could also think about whether this sequence converges or diverges. Now, if it converges, it's going to go towards a particular value. But this one is just going to keep on increasing each time, each time timesing by 5, taking away 1. So we can say that this sequence diverges without a limit. It doesn't get to a certain point and then stop. It's just going to continually increase. Okay, so that's the first 5 terms of that sequence, and then it's what we call its behaviour. Okay, and if you remember, this was the rule of the sequence, okay, which said to get the next term, you times by 5 the previous term and then take away 1. Okay, so let's look at another one. We're going to do the same thing. This time my sequence is defined as un equals 32 over 2 to the n. And it hasn't given us a starting value this time. So to generate the terms of the sequence, we could start with when n equals 1. So when n equals 1, I'd have 32 over 2 to the 1, which would be 16. Then if n is 2, I'd have 32 over 2 squared, which would be 32 divided by 4, which is 8. And then we can carry on like this, so 32 over 2 cubed, which would be 32 divided by 8, which is 4. 32 over 2 to the 4. 2 to the 4 would be 16, so 32 divided by 16 is 2. And then we'll just do one more, so we've got 5 numbers. 32 divided by 2 to the 5. Well, 2 to the 5 is 32, so that just gives us 1. So I can see here that the numbers of the sequence are going 16, 8, 4, 2, 1, and carrying on. Now in terms of the behaviour of this sequence, well, it's definitely decreasing each time. The values are getting smaller, so we can say it's a decreasing sequence. And then if we think about how much it's decreasing by each time, well, each value is being divided by 2. So 16 divided by 2 is 8, 8 divided by 2 is 4, so it's kind of halving each time. So it's just going to get smaller and smaller and smaller, but it's actually going to keep getting smaller and smaller until it gets really, really, really small and will get closer and closer to the value of 0. Okay, and you could do that, test that on your calculator. Since we know the rule is divide by 2 each time, so 16 divided by 2, and then divided by 2, and then you'll see it says answer divided by 2. So we just keep pressing the equals now. It'll just keep dividing the answer by 2. You can see it's gone to a half now, a quarter, an eighth, 16th. Good to have this as decimals as well. It'll just keep going and getting smaller and smaller and smaller. So you can see here, if I press now the decimal button, it's gone to 6.1 times 10 to the minus 5. So that's 0.000, you know, a lot of zeros. So it's going to keep getting smaller, and it's just going to get closer and closer to 0. So we can say that this sequence converges to a value of 0. And in a moment I'll show you how to another way to find that limit with another example. Okay, so one more of these. So number 3. This time my sequence an plus 1 is going to be equal to 1 over a to the n, and they've told us that the first term value of a is 3. We want to find the 5 values of the sequence, first 5 terms, and then we want to talk about its behaviour. So for this one, to get the next value, so to get a2, for this side to be 2, you'd need to do 1 add 1, so n is 1. So you'd be doing 1 over a to the 1, which would be 1 over 3. So far I've got 3, then a third. Then to get a3, so the next term, because n add 1 is 3, our n value is 2, which means we're doing 1 over a2. Oops, write that down there. Okay, so these values should be at the bottom here because they're not powers. Realise I wrote those wrong. So again, if we do 1 divided by the previous one, this one will be 1 divided by a third. If you remember, when you divide by fractions, you flip and time. So this would actually give an answer of 3. So then a to the 4, again you just do 1 divided by your previous answer. The previous answer was 3, so again I get a third. So you can probably see a pattern forming here. We'll just do one more. So the 5th one again would be 1 divided by your previous answer, and the previous answer is a third, so if you flip in times you get 3. So this sequence, in terms of its behaviour, it's not increasing or decreasing. This is what we call a periodic sequence, okay, because it repeats itself. Now this one is a periodic sequence with a period of 2, because it goes 2 terms and then it repeats itself. Okay, if you had a sequence which had 4 terms and then it repeated the same 4 terms, that would be a period of 4, and so forth. Okay, so just want to go back to talking about finding limits of a convergent sequence. So just write yourself a new title. So if you know that a sequence is convergent and you want to find its limit, what you can do is you can set both n plus 1 equal to L and un equal to L and solve for L, and that will give you your limit. So for example, let's say I have the sequence which is defined as follow. Okay, so I know the first term is 6, and to get the next term we always do 2/3 of our previous term, add 5. If I set un plus 1 to L and I let un equal L, I end up with this equation to solve. So what I could do is, this is 1L, so I could take away 2/3 onto this side. So 1L take away 2/3 L leaves me with a third L. So then to find L, I would multiply 3 by 3, which is 15, which means the limit of this sequence is 15. I could check it on the calculator. Okay, so for this sequence it's 2/3 times the previous value. So for the first one we know it is 6 because they told us that, and then we always add 5. Okay, so if I put that in first of all, the second sequence number in the sequence would be 9. Now if you go back now and swap the 6 with ands so that it puts in your previous answer, that'll get me the third number, so it's 11, and then I can keep pressing equals and it will keep running me through all the numbers of the sequence. So after a little while you can see I've got to 14.765888935, and then if you keep going, to keep pressing equals, you can see how the number is getting closer and closer to 15, because the numbers after decimal are turning to 9. It's getting closer and closer, and then eventually on the calculator it will get to a point where it goes to 15, and I'm carrying on pressing the equals button, but nothing is now changing because the sequence has converged and it's not going to change value now. Okay, so you can always check it as well. Okay, so that's the main part of this beginning of the chapter. Okay, so just being able to generate numbers in sequences, understanding their behaviour, so if they're positively increasing, they might be decreasing, they could be periodic, they could converge, they could diverge, etc. So what I want you to do now is, once you've written up some notes on that, is have a go at the exercises that I'm going to email you. It'll have questions and then also answers at the end, and just email me if you need any help.